What is the basic difference between resistor and resistance? So within the circuit, this shows the resistor. This termed as a resistor, and resistance is a thing which will resist the flow of current into the conductor. So each and every material or the conductor has its own specific resistance. Resistance is a property of any material or conductor to resist a flow of current. So resistance will vary as per the material and conductor. We know this formula, that current equals to potential difference divided by resistance. So resistance is property of conductor to resist a flow of current. It also says that I equals to 1 divided by R. That means I is inversely proportional to the resistance. It also means that when resistance is high, the current will be less because they are inversely proportional to each other. So one will be higher, one will be lower. And if resistance is less, then the current flow through the conductor will be high because the resistance is less. So this is called inverse relationship between resistance and current. Now what is the meaning of variable resistance? A component used to regulate current without changing a voltage source is called variable resistance. Once we are placing a battery of 2 volt or 4 volt, and from that if we required certain amount of current, that can be regulated by the variable resistance. It will resist some of the current and it will give us a proper amount of current, and that's why it is known as variable resistance. Now what is the meaning of rheostat? Rheostat is a device to change the resistance in the circuit. Whatever resistance we will see into the circuit and that will resist the flow of the current, if that we want to change, that we can change it through the device, and its name is rheostat. When we will see this kind of sign into the circuit, that means this is a resistor and it will show some of the resistance to the current flowing from the circuit. Now based on the property of the material, that is a conductor, how much it is allowing to pass the current and how much it shows a hindrance or a resistance towards the current, that will give them a name like poor conductor, good conductor, insulator, resistor, and so on. What is electric current? So the motion of electrons. We know that at one side from left to right, if electrons are moving, then in other side the charged particles will move. That means the current will pass from right to left. So whatever current is flowing from the circuit is due to the motion of the electron. So motion of the electron in an electric circuit constitute an electric current. They will be restrained. This is important, that they will be restrained by the attraction of the atoms among which they move. We know that current will pass with the help of the ions. What all positive or negative ions will be there on the surface of the conductor or the metal will help electricity to pass from that particular conductor. But ions are atoms charged species. So attraction of these atoms will get restrained this movement of the electrons, because ultimately they are charged species, so they will restrict the movement of electron through them, and because of that the electric current will face some of the resistance from the conductor. So this is the reason that why the current which is flowing from the conductor will feel some of the hindrance, will feel some of the resistance when it is passing from the conductor. Now based on how the current is facing the resistance, we have segregated some of the materials, some of the metals into the 4 parts, that some of them are good conductors, some of them are resistors, some of them are poor conductor, and some are termed as insulator. So who all are good conductor? So the component which offers a low resistance, that means maximum amount of current will pass from that and they will not hinder the movement of electron. those kind of materials will termed as a good conductor. For example, silver, iron, they are termed as a good conductor because they will offer low resistance. So from which material we are making resistors? The conductor which has a good resistance. It has to be a conductor, then only the current will pass from that. Because we required current over here also and we required current over here also. So it has to pass from that. It has to allow current to pass from that. So it has to be conductor. But it also shows, it has to show some good resistance towards the current. So it will restrict the flow of electron and it will not allow the maximum amount of current to pass from that. So it will show a good resistance. That's why it is known as resistor. Then poor conductor. Component which offers a high resistance. If it shows low resistance, then it is a good conductor. If it shows high resistance, then it is poor conductor. Now what all are the insulators? Household electrical circuits, we have seen the black color wires, red color wires. Inside all are the copper wires. We can see the copper wire inside that, but outside layer of the wires are black, green, red and so on. So this layer which you can see on top of the wires, they are called insulators. Insulators are offer very high amount of resistance, so the current will not flow from them. Even with higher resistance, the components or the materials which has very high amount of resistance, they are known as insulators. Current which is flowing from the conductor, it is also depending upon the length of the conductor and area of the cross section of the conductor. That current will decrease when the length of the wire will increase. So here it shows that one will decrease and other one will increase. So this relationship is inversely proportional to each other. So we can write here, this is a current which is inversely proportional to the length of the conductor. So I have mentioned here L, because one will decrease and other one will increase. So they are inversely proportional to each other, that current and length of the wire. Now current will increase when thickness of wire is increased. Thickness of wire means area of the cross section. Our wire will be always something like this, conductor will be always something like this. So when we will cut or when we are taking a cross section of that, it is something like this in a circular shape. So this is referred as area of cross section or area of the conductor. So both will increase simultaneously. This also tells us relationship of current and area, that they are directly proportional to each other. Both will increase simultaneously and both will decrease simultaneously. Now resistance of the conductor will depend upon three things: its length, its area of cross section and nature of the material. Nature of the material means our conductor is made up of which material, that is silver or iron or aluminium. Based on that material, it will face different kind of resistance. Here it also says that resistance of conductor will depend upon its length. We know that resistance is directly proportional to the length of the wire. Both will increase simultaneously, and that's why it is inversely proportional to current, because as resistance will increase, the current will decrease, and similarly the length will increase, the current will decrease. Again, resistance is inversely proportional to the area of the cross section of the conductor, because here current is directly proportional to area. So that's why area is inversely proportional to resistance. So based on this, we can write another formula that R will be proportional to L divided by A. So resistance is proportional to L by A, where it is directly proportional to the length of the conductor and inversely proportional to area of the conductor. From this we can write R equals to rho L by A. This is termed as a rho, and it is resistivity of the material, and it is material specific. That resistivity of the silver, resistivity of iron, resistivity of aluminium will be different. And this resistivity chart, you will get it in your textbook from the column or from the table 12.2, where they have mentioned all the materials and their different resistivity. So we got here another formula that resistance equals to rho L by A, in which rho is a resistivity of material, which is material specific, L is the length of the conductor, and A is area of the cross section of the wire. From this we can also derive two of this formula, and we have to keep in mind that I is inversely proportional to L and I is directly proportional to A. In turn, R is directly proportional to L and R is inversely proportional to A. So hope this video has solved your doubt. In coming videos we are going to cover some important concepts. So don't forget to subscribe, learn yourself. I'll see you in next video. Till then, keep learning, keep sharing.